Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look at the use of the resource command. Today we're going to look again at the resource command in PowerBasic. This command works both in the console compiler and the Windows compiler. The code for this demonstration is mostly going to be in the console compiler. However, we will be using the Windows compiler later on in the video. One of the first things you may wish to use your resource command for is to embed an icon in the application. If we look at the folder containing our source code, we can see there is an icon at the top of this list of files, add.ico. This is the icon we want to embed within the application so that when a user looks at the application within File Manager, they can see an associated icon with it. We can do that quite easily using the resource icon command. This command takes two parameters. First of all is the name or number of the icon, and the second parameter is the name or the path and name to the icon. So here we are simply saying resource icon, which is going to be referred to using the string app icon, and the icon we're loading is going to be add.ico. If we compile the application now, it will compile quite cleanly. If we look at the folder, we'll see that the exe has now appeared, and the icon that's associated with it in File Manager is the add icon, the plus symbol. When adding icons to your application, Windows will display the very first icon added to the resource file as the icon for the application itself. You can, of course, add multiple icons or bitmaps to the application using this same approach. Next, we're going to use the resource command to embed version information on the executable. If we right-click on the executable and look at properties, and then look at details, at the moment, there is not much information held within this page. There is no file description, product name, or versions. All it's showing is the size of the file and the date it was last modified. So next we will use a number of resource commands to embed this version information into the executable. We start by using the resource version info, which indicates to the PowerBasic compiler that we're about to give it version information. Next we're going to give a file version and a product version value. In this case, I've set them both as being 1.2.3.4. They do not necessarily have to be the same values. The next thing in our resource is the resource string info. This is where we're setting the language ID and the character set. In this case, we're going for US English and the character set to be Unicode. If you have a look at the resource statement within the help file, you'll see there is a long list of different language IDs and character sets. So if you're in a part of the world that doesn't speak English, you can pick a different entry for the language ID. And for the string info, we're currently using Unicode, but if you wish to use one of the others, you merely have to substitute this value. So having determined the language ID and character set, we can now go on to set different version information. So here we're setting a number of different values on the version $ section. The name of the company, the file description, the file version in a string format, the internal name, the original file name, any legal copyright you wish to declare, the product name, the product version, and any comments you want shown to the user. So if we compile that now, it will again compile cleanly, and if we go back into the File Manager and right-click and look at Properties. If we look at the Details tab, this will now tell us the information that we've set up. So all the fields are now populated: the description, the file version, the product name, and so on. It's always very useful setting this resource information on your file so that if somebody else who is unfamiliar with your application clicks on it, they can find out which organization or name it actually has, as well as things like the file and product version. So now that we have that information stored in the resource section of our application, I'm now going to look at embedding files within the application itself. We have in the folder two CSV files, a testdemo2 and a testdemo3 CSV file. So perhaps these are files which your application will depend upon. So that when you roll this application out to the users, there will be three files, the executable and two CSV files. If these CSV files are integral to the way the application works, you don't want anybody deleting or amending them. This can be difficult if the folder in which this application sits is given full rights to the user to make amendments. You don't want them deleting your key files. So we're going to use the resource command to embed these two files within the application itself. This is very easily done using the resource rcdata command. So we're going to call this command twice, once for each of the CSV files. So the resource command is followed by rcdata and then two parameters. The first parameter we're designating as a number, 4000 and 4001, which is followed by the name of the file you wish to embed in the resource. This, of course, could be a path to another folder, or in this case, just a reference to the file within the folder where our source code lies. If we compile that now, it will again compile quite cleanly. If we have a look in File Manager, we'll see that the size of the application has become bigger. Now that we have these two files embedded in our application, how do we get them out? So when the application runs, these two files will be extracted from the resource and placed in the root of the file. So let's create a test folder on our computer, which we can actually put our new executable into. So we'll create a folder called test area. Next, we need to put something in our code so that when the executable runs, it will attempt to extract both of these files and put them into the folder which the executable is currently sitting. So to do that, we're going to create a new function. We're going to call that function saveResource. So this is the skeleton of our new function, taking two parameters, one being the file name and the second the handle. How this will be called in the application is calling the name of our new function with the two parameters, the first being the name of the file we wish to create, and the second is the reference to the resource which has been stored. In this case, value 4000 for the first file and 4001 for the second file. So we're going to create two local variables to allow us to perform this extract. One as a file handle for the file we're about to create, and the second one is going to contain the data which is currently in the resource section of our application. The string variable strdata can be populated quite easily by using the resource $command. It takes two parameters. The first, in this case, is rcdata, to tell the application that we're going to pull the information out the rcdata section. And the second is the handle, the identifier of the section we wish to pull out. In this case, the first call is to value 4000. Next, we're going to open a file, which we're going to dump the strdata variable into. We will first pick up the next free file handle. And next we're going to open for output the file we wish to create. So that's open str file name for output as the file handle we have just populated. And then it's a simple matter of using the print statement to print that string data out to the file. And then having done that, we can then close off the file and end the function. We've put a semicolon at the end of the print statement to ensure that a carriage return line feed is not output automatically. So if we compile that now, it again compiles cleanly, and we're going to copy our resource command and we're going to put it in to the test area. So all we have in this one folder is the single file, the executable. If we double click on the executable, the program runs and it has now deposited both of the files into the root of the folder. So what we've achieved is we've extracted both of the files from the resource section of the application and deposited them into the folder. These can now be read by other parts of the application. And should either of these files be deleted, when we run the application again, they will be recreated. So we can see we can embed files within the application in the resource section and then extract them quite easily. There may be times in your application where you wish to call a DLL. So this DLL would sit possibly within the same folder as your application. And again, we would have the same problem as we do with files. There's always a possibility that this file could get deleted at some point. So let's go into the Windows compiler and create a very simple DLL. If we create a framework using libmain, which gives us the template for a DLL. And we're going to create a very simple function within here that will be exported as part of the DLL. And we're calling this function half-of-value. This function will take one parameter. This parameter is numeric and it is of the single variable type. Having received this value, it will then divide the value by 2 and return that to the calling function. As we're inside a DLL, there are two additional things to remember. We need the export as single as the last part of the function definition. The export is telling PowerBasic that this function is going to be visible from outside the DLL, so that it can be called from other applications. The name of the function, in this case fun half-of-value, is internal to the DLL. The alias is the way the function is going to be referenced from outside the DLL. In this case, we've left them both exactly the same, but they do not necessarily have to be identical. One key point, though, is that the alias is case-dependent, so that when we're calling this function from outside, we'll need to know the casing of the string which forms the name of the function we're calling. So if we save this, we'll call the file simpledll.bas, and we will do a quick compile on it, and it compiles quite cleanly. And if we have a look in our code area, we can see there is our simple DLL.dll. So we have created a DLL which we're now about to call. So since this DLL is external, there are two ways of referencing a DLL and its functions within your code. The first is early binding. The early binding is where we declare this as a function at the beginning of our code. And when the application runs, the very first thing it does is it looks to make sure that that DLL actually exists. So let's put that definition in. So there is our definition. We're declaring the function internally to the application called fun half-of-value. We're indicating that this is an import function. In other words, it's been imported from somewhere outside, and it's been imported from this simple DLL.dll. The alias is the name of the function within the DLL. And as I said, this is case dependent. There is a single parameter being passed to this function, which in this case is going to be a single variable type. And it is returning a single variable type. So how would we call this within our application? So first we will create two local variables, one called value and one called new value. And we will set the original value as being the value 10. So as we know, when we call this function, it's going to take the value we give it and it's going to return half of that value. So we can call this external function in the DLL by referencing the name we have set up in the declaration. In this case, fun half-of-value, passing it the single parameter, which is the original value of 10. And the return of the function is populating the new value variable, which in this case should be 5. So we're going to take that new value and we're going to push that out to our log. So let's try compiling that now. And if we go into our test area, we'll copy first of all the exe and also the DLL into our test area. So we only have the two files in our test area, so when we run the command, it will tell us that the new value is indeed 5. So we have successfully called the function within the DLL. And our two resource files have been pulled out and deposited in the folder. If, however, we delete the DLL and attempt to run the application again, it will complain that it cannot proceed because it cannot find the DLL. So how can we embed the DLL inside the resource section of our application? So let's go back and have a look at the code. We're now going to use late binding on the DLL. First of all, we need to store the DLL within the application just as we did before with the two CSV files. So we'll need to put another resource rc data command at the beginning of the application, so that the DLL at compile time is embedded inside the executable. If we note the size of our exe at the moment, which is 28K. If we compile now and look at the size of the executable, we will see it's now gone up to 34K. So it's added on the size of the DLL into the executable. Now we have to get the DLL out at runtime. So we'll have to use another save resource call. This time we're using simple DLL.dll as a parameter and 4002 as the handle. So this will pull the DLL out at runtime. However, that's not enough for late binding. The early binding declaration means as soon as the application runs, before it's even run a single line of your code, it will look for this DLL, and the DLL at that point in time will not be there. So we'll comment out this declaration as we're not going to be using this one. So the first thing we need to do is to declare a local function. This function is in effect a construct that will point towards the function in the DLL. The function getValue will not exist within this application, but it's taking the parameter we wish to give it, which in this case is a single variable type, and it's returning a single variable type as returned from the function. So next, how do we actually get hold of that within the application? So we will comment out this call we did for the early binding. The late binding does involve a little bit more code. So I'm going to declare two local variables, an hproc variable, which is a handle, and an ASCII 100 character function. This variable is going to hold the name of the function within the DLL we're about to call. Next, we need to do the late binding to the DLL itself by calling a Windows API load library function. So we're going to create another local variable called hlib. This will be the handle to the library, the DLL. The load library command takes a single parameter, which is the path and or name to the DLL itself. If the value returned by this call to load library returns a value which is greater than 0, then the library has been successfully loaded. Next, we need to get the address of the function which we wish to call. So we can get the handle of that function by using another API call called getProcAddress. It takes two parameters, the first being the value of the library handle, and the second being the name of the function we wish to call. If the return from that is greater than 0, then we have got the address call of the function. And we can now go ahead and attempt to execute the function itself. This is where we make use of the declaration getValue we put at the beginning of our code. And we perform this by using the call command, dword, hproc, which is the handle we've just got back, and then the word using, and then our function name, the one we declared at the beginning of the code. And we're setting the output of that to this sng new value. So now that we've got the code completed, let's try a compile. It compiles quite cleanly. Let's go in now and we'll copy the exe into our test area. So the only thing sitting within our test area is the executable. There is no DLL and there are no CSV files. If we try running the code now, we will get the new value coming out as the value 5, which is indeed the value 10 divided by 2. And we can now see in the test area folder that not only have we got both of the CSV files, but we have the DLL. So the DLL is copied out to the folder before we actually call the library. This is late binding. So in summary, what we've achieved today is we've embedded two CSV files and a DLL within our executable. And we're using late binding on the DLL to ensure that the DLL is extracted before we call it. there is of course no reason why you couldn't embed more files within your application. And when the resources are saved to the local drive, they don't necessarily have to be in the local folder. They could be saved to the Windows temporary folder for that particular user. The only thing I wish to add to the end of the application is something to free up the library which we have called. Since we have referenced a DLL in the library, and we've given the load library command to Windows, Windows will have this loaded in memory. As with all DLLs, Windows will keep it in memory until the number of applications which have a handle to it descends to 0. Once it reaches 0, Windows will unload the DLL. So it's always good practice at the end of your application, if you've done a load library command or multiple load library commands to load DLLs into memory, that you use the free library command to inform Windows that you no longer need a handle to it. This saves taking up extra memory in Windows. Hopefully you'll find these techniques useful in your applications, but that's it for today. Thank you for watching.